We're going to complete our discussion about subsets by talking about Venn diagrams. Now, a Venn diagram contains a couple of elements of geometry to it. First of all, what we need to remember is that there's a big rectangle in a Venn diagram that represents the universal set. And so everything that could possibly happen, every element that it could possibly be, has to be inside this universal set. So whatever that is, whether it's rational numbers, irrational numbers, the numbers 1 through 7, the colors of the American flag, whatever it is, it has to fit in the universal set. And when we talk about a Venn diagram has to do with putting subsets inside the universal set. And so what we might say about this is A is a subset of U. A is a subset of the universal set because all elements of A are in the universal set. And so when I have this subset A, every element in it has to be in U. Now, it might not necessarily be every element of the universal set, but every element of A is in U. This leads us to our next discussion of proper subsets. A proper subset would be denoted like this. A is a subset of B, but it's a proper subset. So this symbol here, the sideways U, means proper subset. A proper subset is every element of A is in B. So A is a proper subset of every element of A is in B. But A does not equal B. So it's not every element of B, but it is some of the elements, all of which are in B. Here's what the picture would look like. I've got the universal set here. Here's B. And A would be a subset of B. Not everything in B, but a subset of B. For example, set R equals Mars and Venus. So those are the elements of R. The elements of S are Mars, Venus, and Mercury. So what I would say is R is a subset, proper subset, of S, but R is not equal to S. They are not the same. So that's how this works. They're not the same, so it's a proper subset. Let's look at proper subsets and decide what is a proper subset, what's not a proper subset. I have the vowels here, A, E, I, O, and U, and E, I, O, U, and A. This is A, we'll call it, and this will be B. So A is a subset of B, but not proper, because they're equal. The sets are equal. A is equal to B, and A is a subset of B, but not a proper subset. What about the natural numbers and the integers? The natural numbers is a subset of the integers, but it's also a proper subset of the integers because it's not all of them. It's only some of them. What about the natural to the whole numbers? The natural numbers would be a proper subset to the whole numbers because they're not all whole numbers. The natural numbers are only some of them. What about this next one? This is not proper because they're all the same. They have the same elements. When we find subsets, what we want to do is we want to make an organized list. And here's what that would look like. In example 4, we're going to make an organized list of all the subsets. If I start, I'm going to start out with the empty set. The empty set is a subset of all other sets. And then I'm going to move to sets with one element. Well, the sets with one element, start up here. The sets with one element would be the set with 1 in it, the set with 2 in it, the set with 3 in it, and the set with 4 in it. Those are the subsets with only one element. What about elements with 2, or sets with 2 elements? The set with 1, 2 in it, the set with 1, 3, the set with 1, 4, also the set with 2, 3, the set with 2, 4, and the set with 3, 4. So those are all the sets with 2 elements in them. What about sets with 3 elements in them? I could have 1, 2, 3. I could have 1, 3, 4. I could have 1, 2, 4. I think those are all the ones starting with 1. 1, 2, 3, 1, 3, 4, 1, 2, 4. And I could have 2, 3, 4. And I think that's it. Let me think. 1, 2, 3, 1, 3, 4, 1, 2, 4, 2, 3, 4. Yep, that's it. Sets with 4 elements. 1, 2, 3, and 4. Only one. Interesting to note. This is the only subset that is not proper. So all the rest of them are proper. Let's look at how many we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If we look at 2 to the 16th, or sorry, 2 to the number of elements, 2 to the 4th equals 16. The number of elements in a set is going to give us the number of subsets that are possible. The number of subsets is given by 2 to the n, where n is equal to the number of elements in a set. So already I know up here, if I have an example B, A, B, C, D, and E, if I was going to ask you the number of subsets, it would be 2 to the 5th, which is equal to 32. I'm not going to list out all of those because that would take a long time. But the list is going to have 32 things in it. Now, if we talk about proper subsets, though, how many of them are going to be proper? Well, only one of them is going to be improper. That's the subset that contains all of the same elements as that set. And so the number of proper subsets is going to be given by 2 to the n, the total number, minus that one set. So down here, when I ask you how many elements are in each of the following sets, this is going to have 6 elements, so this is going to be 2 to the 6th, which equals 64. What about this? This is going to be 2 to the 12th, because there's 12 elements. That's 2 to the 12th. What about the empty set? It was going to be 2 to the 0, because it has no elements, so it's only going to have one subset, the empty set. See if you can do these 3 on your own, and I'll just sort of circle them in this greenish mustardy yellow color. I want you to try those. Bring those to class. We'll talk about those. This is the basics of Venn diagrams and understanding subsets. So I hope you watch this. Make sure you do the video summary, and we'll see you next time.